Hello guys, this is Prime Concept. Now we're here to solve problems on electrostatics that we earlier introduced in our previous videos. And let's take a look at the first problem. We have a test charge of this value is placed. Remember, this is a test charge. This is our test charge. Is placed halfway. Halfway simply means at the middle, at the center, halfway between a charge of this and another charge of this. So we have, let's list the charges. Our test charge, I'll be denoting it with Q naught, test charge. So which is positive 1 times 10 to the power minus 6 Coulomb. Then we have our first source charge, which is Q1, positive also, times 10 to the power minus 6 Coulomb. Then we have another one, which is Q2, positive 6 times 10 to the power minus 6 Coulomb. So these are the charges we have. Remember, Q naught is our test charge. And the question says Q naught is placed halfway between Q1 and Q2 that are separated, that are 12 meters apart. That is to say the distance between Q1 and Q2 is 12 meters. So I'm going to draw that. I'll call this Q1, then this is Q2. So Q naught is placed halfway. So I'll place Q naught here. So what it simply means is that the distance from here to this point is going to be 6, since the whole distance is 12. The distance from this to this is also going to be 6. So that when you add 6 plus 6, it gives you 12. Now, the next thing, remember, the question says, find the magnitude, that is to say the size, and the direction of the force on the test charge. Now this, what we're going to apply here is what we did in our previous video, the principle of superposition. Now we have 3 charges here. So we're going to first find the force that Q1 will exert on Q naught. We'll also find the force that Q2 will exert on Q naught. Then we'll get their net force. That is what we're looking for. So I'm going to rub this. I'm going to rub this so that I'll have space. So I want to solve the force between Q1 and Q naught. Remember, Q naught is your test charge. It means that this is your source, this is also your source, right? You would always have only one test charge. Then other ones becomes your source charges. So I'm going to find F1, 0, 1, and 0. So which is K, Q1, Q naught by R1, 0 square. So what do I have here? My K is a constant, 9 times 10 to the power 9, Q1, 4 times 10 to the power minus 6, Q naught, 1 times 10 to the power minus 6, divided by the distance, which is 6 squared. So if you punch this is 9 times this, 9 times 4 is 36, 36 by 36 is 1. So I would have 1 times 10 to the power, this is 9 minus 12, so which is minus 3. So this is what I have. So the next thing I want to find is F20, this and this. So which is K, Q2, Q naught, R20 squared. So if I do this, I'll have 9 times 10 to the power 9. Then I have Q2, 6 times 10 to the power minus 6. Then I have 1 times 10 to the power minus 6. So divided by 6 squared, because the distance here is also 6. So if I do this, I would have, this is going to give us this 3 times this and 7 times this. Okay, so let's punch quickly. 9 times 6 divided by 36. So I have 1.5. 1.5 times 10 to the power minus 3. So that is the force. Now the next thing I want to do is to be able to get my net force. Now let's come back to our diagram. Using the sign convention, I explained in my previous video. So try to watch the video on sign convention. Now, we established from what we saw in the question, this is a positive charge, this is positive, this is positive. And from our sign convention, when you have attractive force is always attracted to the source. Repulsive force is repelled away from the source. That is the sign convention, very simple. Now, when do you have an attractive force? You have an attractive force when you have positive and negative. It gives you an attractive force. If you have positive, it gives you what? A repulsive force. If you have negative, it gives you a repulsive force. So take note, repulsion is repelled away from the source. So this is positive, so it's going to be a repulsive force, which is away from the source. So this is the direction, away, out of the source. Now, I also mentioned anything that is pointing forward, according to our Cartesian coordinate, this is positive, this is negative. So anything pointing forward is going to be positive. So my force here, which is F10, is going to be positive because it's pointing forward, right? Now let's consider these two. These are source, these are test. Both of them are positive. So repulsive force. Repulsion will be away from the source. So it's going to point in this direction, away, out of the source, right? So this is F20. Now, if you notice, the force is pointing backwards. So it's pointing towards the negative, backwards. So it means that this force is negative, right? The next thing I want to do now is to get my net or resultant force. So my net force is going to be the summation of these two. Starting with this is plus F10. This is what? Minus F20. So if we add them up, we're going to have F10 is what? 1 times 10 to the power minus 3. Then you have minus F20, 1.5 times 10 to the power minus 3. So that when you solve that, this 1 minus 1.5 is going to give us minus 0.5 times 10 to the power minus 3 Newton. So we are done. But now if you look at this, we have a negative sign. Negative tells us the direction our force is pointing. So the magnitude of our force is just 0.5 times 10 to the power minus 3. Why the negative sign tells us that the force is pointing backwards towards Q1. So that is the answer, right? I believe that this concept is clear. I'll be solving more problems in the subsequent videos. Do subscribe to my channel, like and share with your friends so that they can also benefit. Thank you. Remember, this is prime concept.